This is Abhijit from CACN, and in this video we'll be learning on how to design a Turing machine for N-crossing. So before getting into the designing part, let me tell you what a Turing machine is and what are its types. So we all know that Turing machine is a device which is used to solve mathematical problems based on its complexity, and different algorithms require different types of Turing machine. So the main term in Turing machine is a head and a track. A track is nothing but the combination of columns is known as a track, which is linearly placed, and a head is going to be the operating part. So it depends on where you place your head. If you place your head in the middle, the operation takes place from the middle part. So it really matters where you place your head. So the operation part starts from head. So let me tell you the different types of Turing machine. So I have named 10 Turing machines here, starting with single track Turing machine. We know that single track Turing machine has only single track, and it has only single head. So based on your placement of head, the operation takes place in a single track Turing machine, and we mostly use single track Turing machine in string acceptance or non-mathematical problems. So you don't require calculations here. So we mostly use here single track in a string acceptance. So here the string elements are being replaced by the alternatives. That is, if I write a single track Turing machine for ABC acceptance, I'll be replacing the first thread A as X, first thread B as Y, and first thread C as Z. So, and the last element is going to be blank. So every Turing machine has a blank space. Initially all the columns in a Turing machine are empty, that is, they are the blank spaces in a Turing machine. So when there's the second one is multi-tape Turing machine. In multi-tape Turing machine you have multiple tracks, and each track is not and all these tracks are not connected together. So these are the separate tracks where they have their own head. For suppose if I take these three tracks are not connected together, and each track has its own head. In multi-tape Turing machine, these multiple tapes are going to operate simultaneously based on their string inputs. This is multi-tape Turing machine. And when it comes to multi-head Turing machine, in a single track you are going to have multiple heads, and each head is going to operate the string. So in this case, if I take the first column and the third column as the head of the string, the first head is going to operate till the second one, and the second one is going to operate till the last of the string. So first head is going to operate this till second column, and second head is going to operate till fourth column. So depending upon your placement of heads and string elements you have, this multi-head Turing machine works. In multi-track Turing machine you have multiple tracks joined together. That is this is a multi-track Turing machine. So initially I have 3 tracks, and all the blocks of this track is empty. That is, it is marked as blank spaces. This is a single track Turing machine. All the blocks all the columns are marked as blank initially, and the more the inputs you have, the lesser the blank spaces you will be having in Turing machines. The next one is multi-dimensional Turing machine. In all the Turing machine we'll be following one direction, that is left to right or right to left. But when it comes to multi-dimensional Turing machine, if for instance if I take this middle element as the head, so it has access to move in any direction, top to bottom or bottom to top, left to right or right to left. So it have the access to move in any direction. It has any direction possible. So this is a multi-dimensional Turing machine. When it comes to offline Turing machine, in offline Turing machine you have access to input your string, but you won't be getting an output. So in offline Turing machine it can read elements, but you won't be getting, or it won't put out those outputs to you. This is offline Turing machine. Universal Turing machine is nothing but the Turing machine which accepts all kinds of problems. It doesn't matter what complexity your problem have. So it just gives output to every possible problem you give. Non-deterministic Turing machine is similar to non-deterministic finite automata, so it has least number of restrictions to follow. So if you have for suppose if you are on track 1 and the head is on first column, so in non-deterministic Turing machine you have access to change any elements. If you are on first track, you can change the element, or you can replace the element with of the third track. So it doesn't need to follow any doesn't need to follow any rules. That is simply non-deterministic Turing machine. Next one is Turing machine with stay option. In Turing machine with stay option, read your string. It has an option to stay, and it can on staying on a column. It gives you an input and output on reading the string. So when you input a string, it reads it and it halts at a position. It can be any position, and based on that position it gives whether the string is accepted or rejected. The last one is two-way infinite Turing machine. We mostly use two-way infinite Turing machine in one's complement or two's complement. So we have infinite number of blank spaces, and between those blank spaces we are going to have inputs. So if I take these blank spaces, these are the blank spaces, and if I want to input any string, you can input from the middle, and the starting point of your string, it has blank spaces on its left, and the ending point of your string, it is going to have blank spaces on right. So this is all about different types of Turing machine. When it comes to the main problem, that is n cross m, so I have two inputs. So this is a mathematical problem. It requires some calculation. So we cannot use single track Turing machine. As I told you, single track Turing machine is only used for string acceptance or for non-calculation problems. So when it comes to multi-track Turing machine, so we are using multi-track Turing machine, and we have two inputs here. Make sure that every input you have, you are going to place it in your Turing machine table. I have two inputs, n and m. So first I'm going to input n in the first track. In the second track I'm going to input m, and in third track I'll be initializing third track as 0. So you might be thinking, what is the reason behind this? So we are initializing third track as 0 because if either of m or n is 0, then the multiplication of or the dot product is going to be 0. So if either of n is 0 or m is 0, the answer is 0. So third is going to your answer is going to be placed in your track 3. So but when it comes to n factorial is a different case. So in n factorial, t3 is going to place your answer, but initially it is going to be 1, because if any of the input, if your input n is 0, and we know that 0 factorial is 1, so initially t3 is 1 in n factorial. But when it comes to n cross m, we are initializing t3 as 0. So so in first track you'll be placing n, first multiplicative number, and in second track you'll be placing m, second multiplicative number. And the third track, initially it is 0, but as you go on to different columns, you'll be adding the third track with the first track. So it is going to be t1 plus t3, t1 plus t3, and so on. We'll be doing this process till t2 becomes 0. So first for step 1, in step 1 initialize t1 as n. Step 2, initialize t2 as m, and step 3, initialize t3 as 0. So these are your first 3 steps. So I told you that we have to continue this process till we reach t2 equals to 0, And the step 4 you are going to do is decrement t2 by 1 every time you pass through one direction to other direction. So except multidimensional, in all the cases you are going to move left to right or right to left. Here we are moving from left to right. So after doing this step, you will be moving to right direction, and after doing this, you will be moving to right direction. So this is the major operation which you do in n cross n. For example, if I take 5 into 5 into 5, so first step 5 into 5, right? So first step, first put m in so let me take different numbers, so it will be like n square. So 5 into 6. So first put put n in first track t1. Step 2, put m in track 2, and step 3 is initialize track 3 as 0. We are going to do this process till we reach t2 equals to 0. So in first track it is going to be 5 itself, and in second track you will be decrementing 6 by every time you pass from one column to other column. You will be decrementing 6 to 5, 5 to 4, 4 to 3, 3 to 2, 2 to 1, and 1 to 0. So your answer is going to be here as 0 ends this process, and we are going to have our answer below 0 in track 3. So let us see. We know that 5 into 6 is 30. So if this satisfies this, our problem is correct. So first thing, track step 1, initializing m as first track as n, second one as n, third one as 0, and we are going to stop this process on reaching t2 equals to 0. We are decrementing t2 by every time we are moving from one column to other column. And next step is adding t1 and t3. So first next step, 5 plus 0, 5, 5 plus 5, 10, 10 plus 5, 15, 15 plus 5, 20, 20 plus 5, 25, and 25 plus 5, 30. So this is your answer. So this is all about m cross n. So let me show you once again. So initially I am placing m in the first column, n in the second column, and initialize third column as 0. And next step is decrement t2 by 1 every time you change the column from one column to other column, and process the t3 equals to t1 plus t3, t3 equals to t1 plus t3, t3 equals to t1 plus t3, and you are going to follow this process till you reach t2 equals to 0. On decrementing 0, t2 should be 0. On decrementing t2, the t2 should be 0. Till this we are going to follow this process, and in m cross n we are initializing t3 as 0 because if either of m or n is 0, the answer is 0. When it comes to n factorial, we will be initializing t3 as 1. So if the case comes where n equals to 0, n factorial is 0. Mostly we are going to perform a Turing machine for 3 tracks itself, but when it comes to exceptional cases such as finding prime number or a logarithm of any number, we use more than 3 tracks. We use 4 tracks Turing machine, but mostly we use 3 track Turing machines. Thank you.